4.5 part 2 wants us to graph y equals a tangent of bx minus k. Same thing pretty much, I just changed the equation a little bit, but it's the same as what we've been doing. So it says here, first thing we're going to do is we're going to find the vertical stretch factor, which is your absolute value of a. We're going to find your period. Now remember the period for tangent, the parent function was pi, so to find the period of a transformed function, it's going to be pi over b, and then our phase shift is still going to be our c value. So after we do that, we need to find our two vertical asymptotes. So remember before, the parent function, the x part, let me write it up here. So when we had just y equals tangent of x, this was what gave us that negative pi over 2 and the positive pi over 2, which was where my vertical asymptotes were. So now we're going to take that part there, the bx minus c, excuse me, and we're going to set them equal to those old vertical asymptotes. So we're going to take that b times x minus c and set it equal to negative pi over 2. And we're going to take that b times x minus c and set it equal to the positive pi over 2. Now, what's the difference between these two things, basically? There's not one. They put a k up in there because they had distributed their b, so it's not officially our phase shift. So whatever you have there, it doesn't matter which form it's in, if b is inside the parenthesis with x, or if b is outside the parenthesis right in front of the x, you're going to set them equal to negative pi over 2 and pi over 2 to find those vertical asymptotes. Then we're going to, 3 and 4 basically tells us we're going to create our table. And so we're going to do our table just like what we did with the other tables. We're going to take the first point, which we're going to know because that's what we're finding when we take the b, set that equal to negative pi over 2. And we're going to take the last point that we're going to know, which is where we set that equal to positive pi over 2. And then we're just going to create our intervals in between them. And in step 5, it says to graph. So let's try this in example 1. Okay, so example 1 tells us we're going to graph y equals 3 tangent of 2x minus pi over 2. Alright, so first thing I'm going to do is I'm going to write out my tangent parent table so I can use that when I go to do my y values. So I remember it started at negative pi over 2 and it ends at positive pi over 2 because that's what I'm going to have to use to find those vertical asymptotes. And so I'm going to do halfway between them and then halfway between those little intervals. The tangent, remember, is our weird one. It starts out with an asymptote and then tangent starts at the bottom and just keeps going up. And then it ends with another vertical asymptote. Alright, so the first thing let's do now is let's find our A, B, and C like it told us to. So we know A is going to be 3, which the absolute value of that is going to give us our vertical stretch factor. So that would be the absolute value of 3, which is 3. Alright, B is a 2. It's still the number in front of x. Doesn't matter if it's inside or outside those parentheses. And so this is going to give us our period. Which remember, we're looking at tangent, so our period is pi over b. So our period is just going to be pi over 2. Now when we go to find our c, well, if we want to look at our phase shift, we got to take that 2 out. So this is the same thing as saying 3 tangent, oops, use the bracket like they did before, of 2 times, we'll divide both of these by 2, and so I'd get x minus pi over 2 divided by 2 is a pi over 4. Okay, so my phase shift is going to be, we're going to go to the right, pi over 4. Right, so let's create our table. Actually, let's find, sorry, that was step 1. So step 2 said to find those vertical asymptotes. So it doesn't matter if we use what was given or we use this new form, we're going to set them both equal to, or we're going to set it equal to a positive pi over 2 and a negative pi over 2. So I'm just going to use what they gave us. So they gave us 2x minus pi over 2. So we'll set that equal to negative pi over 2 for my vertical asymptote on the left. And 2x minus pi over 2 equals positive pi over 2 to give us our vertical asymptote on the right. So we're just going to solve both of these. So add pi over 2. So 2x equals 0. Divide by the 2. And so we find that it's going to be at 0. Do the same thing here. Add pi over 2. So we get 2x equals pi. Divide by 2. And so x equals pi over 2. And so we can check these, because if we know that they're our beginning and our end point, they should also be a period away from each other. Is 0 and pi over 2 away from each other? It is. Alright, so for my new table then, I know it's going to start at 0, and I also know it's going to end at pi over 2. So what number is halfway between 0 and pi over 2? Well, if nothing else, add them together, divide by 2, and we get pi over 4. But then what's halfway between 0 and pi over 4? Well, I'm going to write that one out because we haven't done it. So add them together, divide by 2. So we got pi over 4 divided by 2. So in your calculator, you could do 1/4 divided by 2. It's going to give you 1/8, and you put pi back on top. And then what's halfway between pi over 4 and pi over 2? Well, we could do the same thing. Add the 2 together, divide by 2. It's going to give us 3 pi over 4 divided by 2, which is 3 pi over 8. And if you're not sure, if you think that looks weird, check it, guys, especially when you start at 0. So this is 1 pi over 8, which means the next one should be 2 pi over 8, 3 pi over 8, and 4 pi over 8. And it is, so we know we got those right. Now for our y's, we're going to do just like what we did before. The only thing we have that affects our y's is that 3 at the beginning. So we're just going to take all of our y's and multiply by 3. So undefined times anything is that still undefined. Negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3 is 3. And undefined times 3 is still undefined. And then all we have to do is graph those points. So let's draw our graph. Make sure you put a scale on there. Now I'm going to put this out a little bit because we got pi over 8. So I'm going to go negative pi over 2 to positive pi over 2. Stretch it out a little bit. And then I can see I definitely have to go up to 3, and I definitely have to go down to at least negative 3. Alright, so for my asymptotes, I'm going to draw them in. Oops, wrong spot, so sorry. Let me turn the marker on so we can see that a little bit better. So we're drawing our asymptotes. Alright, and then we're going to plot our points. Now if you're unsure where your points are, we know, because we set this up, that halfway between 0 and pi over 2 is pi over 4. So we can just put a point there. And then we know that halfway between 0 and pi over 4 was our pi over 8. And then halfway between pi over 4 and pi over 2 was our 3 pi over 8. And so we can graph our graph here. Just let it be shaped by your asymptotes. And so you can see there we did have that vertical stretch that it showed us in part 1 there of 3. And we can see our period is from 0 to pi over 2, so it is pi over 2. And if you remember the parent table there, it does show our shift as well.